Good afternoon, sir. Yes, good afternoon, sir.
Good afternoon, ma'am. Good afternoon, everyone.
Good afternoon, sir.
Yes,
Can we start?
within 2 minutes we will start, sir. Few
Yes,
students are
yes.
still joining.
Yes. No problem. No problem.
Okay, sir, we will start. Good afternoon, all. This is Professor Jahida Subedar from School of Mechatronics. I welcome all to the expert session on robotics and automation by Mr. Bharat Gite, Director, Park Robotics System Private Limited. The company is specialized in providing customer-based end-to-end solutions in special purpose machines, robotic systems, and line automation. Before venturing into the Park Robotics, he was associated with TAL, that is Tata Automation Limited, and PARI. With this short introduction, I would request Mr. Bharat Gite to take over the session. Yes, sir. You can.
Yes. Thank you, ma'am. Thank you. Uh, Good afternoon, everyone. So, as per our today's topics, we will not take your too much time. We'll just travel towards our presentations, and as per the topics which we decided in the today's session, I will introduce and I will give a small introduction about myself and regarding about my organization, that is a Park Robotics Systems Private Limited. So right now I will start on the presentation. So if you see, this is small presentations. I think all of you visible. Ma'am, can you help me? Can you see the presentation?
Yeah, it is visible.
Hello.
Yes, it is visible, sir.
Yeah, it's visible. So nice,
Yeah.
very fine. Thank you very much. So now I will start with our today's topic, that is robotic automation for the industry. This is a topic where we cover below points, which is our today's main agenda. First is to a small introduction about the myself, Mr. Bharat Gite, as the owner of Park Robotics System. Second is the introduction to Park Robotics Systems Private Limited. Introduction for that because we all of you should know the what activities of automations and robotics applications are going on, so that you will get the better ideas of the automation solutions. For that purpose, I will cover the one topic of process which is handled by automations, robotics, and other types of. That is the one process which are going to cover by is the welding automation. Why welding automation? I will tell in next session or next topic when that points comes. Okay, next is the introduction of welding robots, because the welding robots, how we use the robot for the welding automations, we are going to cover over here. Next one is the process and equipment of the robot integrations. Means for the integration, for the robot integration, what are the equipments required for the integration to run robots for the automation purpose? There is some process and some equipments which may be new for you, so I want to cover this in these sessions. And at the end, I'm going to show you one small example of robotic automations which going in par robotics. So that will also give better idea to you peoples how the industry using the robot for the automations and how the automation process is going on.
Okay, sir, 1 minute. Your presentation is not visible now. Only this logo is visible. Only logo is visible. Presentation is not visible, sir.
Presentation is not visible. So now I just present. Give me 1 second. Okay. Just a minute. Now it is visible?
No, sir. Only logo is visible.
Okay, so I will just presentation, your entire scheme. Now is it?
Yeah, I think it will.
Yeah.
Yes, sir. Now it is visible. Yes.
Okay, now this is a front page robotic automation for the industry, and the topic is explained. Just it is visible to you.
Yes, sir.
Okay, na? Yes.
Yes.
Now just give the topics which we are going to cover. Now I am going to first topic is myself. Myself is the Bharat Gite, as the owner of Park Robotics System Private Limited. I have the complete total year of experience, 20 years in the automation industry as a design field. And I completed my BE Mechanical from University of Pune in 2000, sorry. And my last college is Sanjeevani College of Engineering, Kopargaon. So I now continue in the automation field. I started my own in 5.5 years back, 5.5 years back, and I'm working as a owner for the Park Robotics. So small introduction about the Park Robotics is the Park Robotics is the complete automation solution provided for the two-wheeler and four-wheeler segments. Means all the two-wheelers manufacturers, OEMs, their tier one suppliers, and the four-wheeler like Tata Motors, Mahindra, four-wheeler like Hero Motocorp, Honda motorcycles, and their tier one suppliers. Tier one supplier is the manufacturer, part manufacturer for the built up of two-wheeler or four-wheeler. So these tier one suppliers are manufacture their basic parts, frames, or seat or C wheel like this, and they supply to OEMs. They manufacture or assemble the vehicle to sell in the market. So we are working for the OEMs also and for the tier one suppliers also. So our base area is the welding automation solution. We are providing the complete welding automation solution to the two-wheeler and four-wheeler. So accordingly, that parts we are going to cover in today's session, how Park Robotics works. For that, to get the small brief idea how the Park Robotics work, I have the small presentation of 5-6 minutes to see you. You just go through that, so you will get the overall idea of Park Robotics and the products and how the automation is going on. So I will just on that automation link, presentation link. Hello. Hello. Hello.
Yes.
This side.
Yeah, it is visible.
This
If
side.
the audio is not clear, it's okay.
Video चालू है ना? ऐसा yes, yes. Okay. Okay.
Sir, we are not able to hear anything.
Yeah. Generally, for the videos in the presentation, we do not get the audio clear. So we will ask for the video. Okay.
Hello.
Yes, sir.
So this is the basic small presentation of Park Robotics. Can you hear me?
Yes, sir. Now it is audible.
Yes. I think that video you are not getting the voice, correct? No?
Yeah.
It is only background music and small introduction, but it is not so important. So visual is important. So you get idea about the welding automation a little bit. What's going on as per the automation requirements. Okay. So now we are moving towards the next topic. Now the introduction to process and types of welding. Now why I select the topics of welding. Now I think you get the idea, because Park Robotics is 90% involved in the welding automation. So we cover today's, because automation is very vast field, because you can do any process by automation. The sky is the limit for the automation. So we'll cover the welding automation which we are handling in our organization, and I will give the brief idea about the welding automation. So I will give the small introduction on the process of welding. So as the engineering student, everyone know the what is a welding, what is the process, and what are the features and how the process is going on. But I will explain a little bit in details because it is very important for the automation field. If you see the in picture, you are seeing the welding torch. Welding torch is the part is handle when the grip is there for the gripping the gun torch. Silver nozzle is there. Inside the nozzle there is a tip, which tips allow the feeding wire. If you check the cross section of the torch in your left side, you can see the nozzle contact tube. We can say the contact tube inside. Outside is the gas nozzle, and inside the contact tube there is a consumable electrode. That's the consumable metal wire is there, which is going to melt in welding applications, and the fusion of two parts is going on there. And in between nozzle and the contact tip, you can see there is a space where shielded gas are come, because to forming the welding application or to form the weld, there should be a spark or heat generated in between positive electrode and in between the negative electrode, means from the wire and the component. Spark should generate, heat should be generated to melt the component and to form the welding bead. So to complete this process, we require gas outside the spark. So we passes the gas from the nozzle, from the torch or from the welding gun, so that it shield the welding arc, and the welding process is completed with 100% efficiency. Because how the shielding gas affect on the welding penetration, I have the small clip on that also. If you check the next slide, it shows which are the welding shielded gases using for the welding application. It's a CO2, argon plus oxygen, or argon plus CO2. It depends upon the again percentage. If you see the chart beside of that, maybe because of small screen you not be visible, but if you see in detail, if I use only argon, the penetration is maximum and the bead size is low, and the spot dikha hua hai wo, that is a spark, that spatter you can say. While welding the any material, spark are generators, जो sparkler type spark generate होते, it unnecessary, but it is generated in the post process. So to minimize that process spark, we can use the different types of gases. If you check the if I use an argon gas, there are later spark, less spark, and high penetration. And if I use 100% CO2, it gives the less penetration, big bead, but it gives more spatters. So this is very important factor in the welding application. What gases we are using and how we can achieve the better penetration and the less spatter. It depends upon the combination of argon gas or oxygen gas, argon gas or CO2 gas. So this is some little bit idea which I want to give in welding applications. So I think you get the idea about the welding automation. So which process mostly following in the automations is the MIG welding. MIG welding means metal inert gas welding, which is comfortable for the all MS mild steel fabrication components, means for the two-wheeler chassis or four-wheeler fabricated components, or sign stand of the components. All these welding processes are the MIG welding, which is the maximum usable process in the automation. So this is the one important basic process is the arc welding, CO2 welding. Welding electrode is there, and the current is passes, and the spark is generated, and parts are welded. But standard procedure followed to the industries. Second process is the tungsten gas arc welding, means TIG welding. It is used for the seam welding, or it's a tungsten welding electrode used for the spark generation. In the MIG welding, we check that metal fuel filler wire, which is a consumable in that applications, that used as a electrode to generate the spark. It carries the current. Now in the tungsten electrode gas welding, it's a TIG welding process. Here tungsten electrode is there, and it gives very less pattern, very less heat, and it gives the smooth welding bed. It is used for the thin materials, sheet metals, and for the mostly for the seam welding. Seam welding means it's a butt type of welding, not a T type welding. Seam is to paste when to components two sheet metals, or in the case of round pipe, when a circular sheet I fold it, and when joined it's form a seam. At seam welding we can mostly preferable use the TIG welding. Next process is a submerged arc welding process. This is also one process of MIG welding or arc welding, where we use submerged, means shielded some extra material like stone or small stones layer on the welding bed, so that it gives the less exposure to atmosphere, so that we can give the better welding penetration and weld shield, good shield rather than gas. So this is also one another procedure. Flux core welding, it's another example of the welding application. And now laser welding is the one new version comes a couple of years back. Now we are mostly looking for the laser welding also, because with very high speed applications we can use a laser welding. It gives a better performance, less pattern, and the good weld quality. But right now it's a costlier solution also. Not industries persons or most of industries not following that, because of it gives a very high cost. Okay, so this is about the regarding weldings. So next topic which we are going to cover is the introduction to robots. So if you check robots, means in front of you there are multiple types of robot, human robots, some handling robot, some vehicle robots, all types of robots are available. But this is a special type of robots which is used for the welding application, which I am showing. It's a welding robot with a 6 axis of movement. It has the 6 axis of movement, where I can cover the any profile, straight welding, round welding, a curve welding, any type of welding I cover with these 6 axis of movement. And it has number of payload capacity from 2 kg to 30 kg, depend upon your applications, small gun or high welding torch. It has the different types of welding speed. It has a different acceleration, repeatability. If you check, it is less than 50 micron. So that is the very good accuracy level of these robots. It gives the precise welding form or precise application. We can use a robot for the welding. And the robot make, if you check, there are number of robot makes in the world. If you check in India now, Tata Motors is enter in the robot making. From other side, from Japan, you can see Fanu, Motoman are the robot makers from the Japan. From Germany, you can say Kuka, ABB are the robot manufacturer for the typical applications. So this is the main important applications of the robot in the welding application. One important features now robot is going to handle if there is a variation in the bead, welding bead or component, because for the welding component, if in the because of manufacturing inaccuracies, welding bead may vary. Because for the robotic application now, the if you know current scenario, because there is shortage of manpower, shortage of expert welder, because welding process is a process which is depend upon the skill and that operator ability. So if the skill operator is there, you can get a very good quality of welding. And if operator is not so skilled, so you will not get the proper welding bed. So in that situation, robot is very good solution for the welding application, because right now for welding, atmosphere is very hot and dirty and all this. In that atmosphere, no one is ready to work for the as a welder for that proper for that area. Specific peoples are ready to work, not the all or not general peoples are working for. So in that case, all of industry is asking for the welding robots, because it gives a better quality, better accuracy, and it work with 100% efficiency. So for robotic welding, one important factor is their input should be correct, because robot is a programmable device. Once I program to weld in this area, suppose for straight go straight for 100 mm, take 100 mm right 90-degree and complete a circle welding. So that program is fixed to robot. So robot 100 or 1000 times is follow only that 00 within 50 micron accuracy, you will follow that path. For that purpose, we need correct input component. If the input component, because of manufacturing irregularities, it is not 100% possible to give the 50 micron component for the robot welding. In that case, if there is a variation of 1 mm or 2 mm in the welding bed, so now again the robotic industry introduced one laser seam tracker. This device helps robot to track the seam first. He moves in front of the welding torch. He track the seam where the seam is shifted 1 mm in plus side or minus 1 mm in minus side. It gives the feedback to robot, and again robot correct his position as per the seam tracker input. So again, this is the advanced technology which gives the better accuracy in inaccurate areas also. So this is the advanced technology now industry that are using, but because of again it's a costly solution, so most of the peoples are recommend to give the input component in correct condition, so that he can give the better result of in building application. So this is the basic about the robots. Now we'll move towards the equipment which are using for the robot integrations. Now the basic robot comes with main manipulator with the 6 axis. It has a 6 axis, 6 motors, servo motors to rotate individual axis in individual position. So this is the one manipulator with 6 axis of movement. One is the robot controller. Controller, it's a control unit which programmable unit where I can program all the axes in individual directions. So that is the one controller comes with that robot. And one is the programming pendant. That programming pendant helps us to give the inputs or to make the program of the robot. So this is the standard units come from the robot manufacturer, because we are the integrator. We are given the automation solution, so that standard product is available market. We take these standard robots and integrate this unit in our applications, like for welding applications or for handling applications or for some painting application. So it depends upon the application. So if we check the robotic applications, in the robotic welding applications, in the right side diagram, it shows the all the equipment required for the welding automations. If you check, there is a robot controller, there is a motorman controller. This is an example of suppose motorman robots. It shows the one robot is there. Backside is the robot controller. Robot controller is the programmable unit for the robot movement. Backside of the robot controller, there is a control stabilizer. If the input power source required to the controller, then top side you can see there is a wire feeder on the robot. As I said, in MIG welding application, MIG welding process, there is a inner metal wire is there, which is a consumer product for the welding applications, and it carries the current. So that wire should be continuously feed to the robot, so that we can complete the welding, because it's a consumable. So there is a wire feeder. It's again a unit comes in the markets. This is mounted on the robot. It continuously feed the wire to the welding gun, so that we can completely weld all components. And to feed the wire, there is a conduit cable, that is a wire spool. It's a bunch of wire. It's available in the market. We just connect it and we are consuming using the wire for the welding. And as I said, the one is the gas connections. Gas connection required for the shielding of the gas. So we connect the wire to the robot welding gun. We connect the gas hose to the welding gun to shielding the welding torch. That wire feeder which is carrying the current to generate the spark at the welding point, and the back side is the robot controller where I can program anything, anywhere, any direction, so that if I once program and I on the gas and on the wire feeder, I can continuous run for thousands of hours without interrupt of welding quality or welding efficiency. So this is the most important benefit of the welding application in the industry. So this is the process how robot is work in the industry, how they integrate, how they connect, which are the important inputs required for the welding automations. So next is we'll go to next process, that the actual how. Now I just discussed all the equipments that are available, how the process is going on, how the automation is going on. So now I will give one small example how Park Robotics or any automation industry, how they work for the industry, because it's a practical thing. Everything is okay, theoretical on paper is different, and the actual industry how they works for to give the actual products. So I will give one example of how the customer give the inputs, how in this way we work out and give the solution. So first, as a customer requirement is the welding automation for frame line or swing arm line. Frame line is, if you see right side, there is a 3D model of frame. That is the frame of Mahindra two-wheeler. If you check on the road, now Mahindra launched new vehicle, that Mahindra Java. That vehicles have one chassis. Inside the chassis, that chassis means the tubular structure where all the parts are mounted: front wheel, rear wheel, vehicle tank, fuel tank, seat, everything is mounting on this frame. So this frame, we have to give the solution for this frame formations. So now customer doesn't have any inputs, they have the only 3D model. We have to give the solution how to form this model or how to productionize this frame. Now they have, suppose they have the requirement of 60 seconds per frame, means in a 1 minute they have to manufacture one frame. For that application I have to design one line, I have to give the solution for the manufacturing of this frame in a one frame in a minute. So that part, for that purpose I define the process. I will show one example of which I define the process for that application. I just open that sheet. So this is the one basic process for this technical frame. The model given by customer is now in front of you. This is a 3D model. As they design actual vehicle, from that vehicle they pull out the skeleton of the vehicle, that 3D model, and give to us for the development. So accordingly we process the complete frame. As you see, if you check operation 1, I take the one tube, suppose front side. Front side is a one head pipe tube. We are saying that head pipe tube and small part. There is a 50 mm welding for that part. Again, second process, there is another patch. How to weld that first. Now second process, another subassembly. Third process, another subassembly. Now in this way we are building, developing one and one complete subassembly. Again, now we come to the skeleton formation. Subassemblies or child parts we manufacture earlier. Now we are bringing in one common assembly fixtures that get connected. Now another child part we weld in next stage. Remaining part again weld in next stage. Next process. Again remaining small child part weld in next process. And now the frame is formed as per the, if you check 200, OP 200. So I started from OP 10 up to 200 in a 20 stations. In a line of 20 stations is required to form this frame in complete automation, and each station have the cycle time of 1 minute. So I have to design line accordingly. Each station should complete his activity in 1 minute so that I can get output of one frame in 60 seconds or in 1 minute. This is the one example. Now the process is finalized. I have another one process of the swing arm. I think that is swing arm is a rear wheel. If you know, the rear wheel is mounted in swing arm, the chain sprocket and everything. It has a shock absorber. It moves up and down on the road. So this is also one process of swing arm. We define the layout also. Where is the robot? How robot is going on to weld on different stations? How operators are? How many operators require for the line? This all basic process and layouts are defined in the organization before starting the design activity. Now, after completion of process, we go for the final design. I will show one example of final design also. The swing arm process which we defined earlier. Now that this is the process of design. Now, as per the requirement input parts, we design a fixtures. For second to stage 3, for next process, next stage, we design the fixtures for the holding individual component, because input are the loose component. I have to hold in a vehicle mounting condition and I have to weld it. So it complete design activities, 3D modeling design as per the vehicle requirement, as per the complete assembly drawings, and we get the approval from customer. So this will be our design activity, and fixtures line will be like this. Now this activity is completed. Now after completion of designs, we started the manufacturing. If you know, most of the people's, I think, aware. Once I completed the 3D model, we convert into 2D manufacturing drawings. Individual parts will get manufactured, and individual parts again get, after manufacturing, it get assembled in the fixture, and fixtures are ready for with inspection for the part loading. So in between process is the manufacturing BOP process. It is a parallel activity after the design manufacturing. So now I will show the assembly integration, how the assembly is going on. I think we have some photos of the existing. Now, if you see the one photo where is the assembly is going on. Robotics cell, one cell, second cell, third, whatever the 20 stations we discussed in last PPT. There are 20 stations for completing one complete frame. So this, like this way, station OP1, OP2, operation 10, operation 20, operation 30. So in this way, all these 20 stations are manufactured and assembled, ready for weld. Now you can see the robot also. There is a welding torch also. All the equipments are get assembled at the back side. That welding power source, gas hose, wire spools. In this way, line is ready for the trials. So this is the process. I have another second example of the robotic cell integrations. How the control panels, authorization box, cycles and control elements regarding, it's not a mechanical, it's a control related cycle authorization, robot start button, clamp, declamp, everything is we have to prepare and mount on the robots for the integration and to give the cycle start to the robot. So once I complete the assembly, all line is completed. Now we are going to conduct a trials on the input parts, because input parts are come from the tier 1 suppliers. We have to assemble here, weld here, and complete the final inspection. So again, I have the small video on the how process is going on, or actual after manufacturing, how it's run. So I will show that video so that you will get the better idea. So you see complete line how these all the stations are working for the optimized time and how the parts is formed from start to end. Now if you check at the end, we form one swing arm with complete inspections and the correction station also. So this is the basic process how from start, design, manufacturing, assembly and execution on operators customer side is going on. This is the process I want to show. So you get the better idea on this. Now after welding automations, I have one solution or one topic on the actual riveting automation, because as I told, 90% of works of welding automation is going on in the park robotics, but some 10% or 15% we are working for the other special purpose machines or some other automation solution also. So one I want to show one automation solution of riveting. We have complete live video for the riveting machines operations. You can see how that working, what's the operation is going on. I prepared that video for the training purpose, but you will get the better idea on the elements which automation products we use for the applications and how they work. So it is better you go this video and you can check. So now that's all about the riveting automation, where it is non-welding automation, and it shows required components used for the automation, how the PLC controller is working for selections of the different components, and how the process is going on for the multiple variants. So this is the again one example of automation. So I think we covered all the required topics today, and that is the things we are going to present as per the requirement. So that's all today. Thank you very much for the sessions, and thanks
Yes,
for. So hand over
okay,
to.
sir. If
Yeah,
students are having any doubts, they can ask.
yeah, definitely they can ask, no problem.
Yes, sir. Yes, students. Now you can ask the questions, or you can type your question in the chat box.
Good evening, sir. I'm Darshan Gaware from Mechatronics first year.
Good evening.
So my question is, where do you see the field of automation in the coming 5 years? Like, is it only related to automobile parts, or is there any diversified scope for the automation sector? Like, what are your views on this?
Now current the automation expectation is the agriculture is the most important field for the automation, which is unseen area for all the coming persons. Automation is everyone is focusing on the automation, but you can check for the agriculture and the medical equipment also coming up area for the developments.
Okay. Thank you, sir.
Yeah.
Yes, students, you can type your question in chat box also.
Or you can share my number to your members or your student. They can text me anytime. I will reply on that. No issue.
Okay, sir.
Yeah.
I guess, students, you don't have any questions. Yes, is there any question from student side? Okay, sir. Thanks for giving today's session on welding automation. Particularly, we got some basic information about the welding automation, and we saw the robots which are used for the welding automation. And doing whatever we are learning in the academic subjects like robotics, industrial robotics, designing the robotics part. And
Yeah.
I think some information students are able to relate whatever you have explained initially about the degree of freedom, and what they are studying in their subject. And
Yes.
yes, sir. Thanks a lot for today's session, sir. And if we need any help in this particular field, we will definitely contact you regarding the robotics and automation.
Yeah. Always welcome. Yeah. No problem.
Okay, thanks, sir.
Thank you. Thank you. Thank you.
Thank you, sir. Thank you, sir.
Yes.
Thank you, sir.
Thank you.